Welcome to our explainer. Today, we are going to tackle three concepts that honestly run the entire world: work, energy, and power. And no, these aren't just abstract ideas. They are the literal rules of the road for everything that moves, from a tiny pebble to a massive star. So, let's start with something we've all felt. Picture this. You're pushing a huge, heavy boulder. You're straining, sweating, your muscles are screaming. You feel like you've done an incredible amount of work, right? But what if I told you that, in the language of physics, you haven't done any work at all? I know, that sounds completely wrong, but that little paradox is actually the perfect doorway into understanding what these terms really mean, because the way scientists use them is way more specific than how we do in everyday conversation. So, let's get into it. Here's how we're going to break it down. First, we'll get a new definition for work. Then we'll talk about what fuels that work, which is energy. We'll look at the two big types of energy, see how they trade places with each other, and finally, we'll bring in power to see just how fast all this stuff happens. All right, first up, work. Look, in our normal lives, work is anything that makes us tired, right? Studying, thinking hard, holding up something heavy. But for a physicist, it's a whole different ballgame. So check out the difference here. On the left, you've got things that definitely take effort. But on the right, you see a pattern. In every single case, something is actually moving. Physics doesn't really care how tired you are. It only gives you credit for work if you've made an object move from point A to point B. So for work to officially happen, two things absolutely have to be true. One, you've got to apply a force. And two, the object has to move because of that force. If it doesn't budge, like that wall you were pushing on, sorry, but in physics terms, that's zero work done. And of course, we can put a number on it. The formula is super simple. Work equals the force you applied multiplied by the distance the object moved. And the unit we use to measure this is the joule. Okay, so if work is the action, what is it that lets you do the action in the first place? Well, that's where energy comes in. You can think of energy as the currency you spend to do work. It's the fuel in the tank. The definition is beautifully simple. Energy is just the capacity to do work. And here's the dead giveaway that they're connected. Notice the unit? It's also the joule. That's because they are two sides of the very same coin. The amount of energy you use up is the exact amount of work you get done. Now, there are lots of types of energy, but we're going to focus on one big category called mechanical energy. This is basically the energy an object has because of its movement or its potential to move, and it breaks down into two really cool, distinct forms. And here they are, the two stars of the show: potential and kinetic energy. You can think of it as stored energy versus energy that's actually in action. Okay, I love this comparison. Potential energy is like a drawn bowstring. It's full of stored energy just because of its stretched position. It's waiting. Kinetic energy, that's the arrow flying through the air. It's the energy of pure motion. One is potential, waiting to be released, and the other is that potential in action. So for something like gravitational potential energy, the formula is just its mass times the force of gravity times its height. Basically, the heavier something is and the higher you lift it, the more potential energy you're packing into it. Kinetic energy, on the other hand, is all about mass and speed, or velocity. The more massive it is and the faster it's going, the more kinetic energy it has. But check this out. The velocity is squared. That means that doubling your speed doesn't just double your energy, it quadruples it. Speed has a massive impact. Now we get to the really mind-blowing part. These two forms of energy, potential and kinetic, aren't separate things. They're in a constant dance, always transforming from one to the other. This right here is one of the most important rules in all of science, the law of conservation of energy. It basically means you can't make energy out of thin air, and you can't make it disappear. The total amount of energy in the universe is fixed. It just changes its costume. A falling ball is the perfect example. When you hold it way up high, it's not moving, so it has zero kinetic energy. It's all potential. The second you let go, it starts to fall faster and faster. That potential energy is converting into kinetic energy. And right before it smacks into the ground, it's at its fastest point. All that potential has turned into kinetic. The exchange is complete. So let's recap. We have work, the action. We have energy, the ability to do the action. But there's one last ingredient we're missing: time. How quickly are you doing that work? Well, my friends, that is power. Take a look at these two workers. They're lifting the exact same box to the exact same shelf. That means they both did the exact same amount of work, right? But worker B did it in half the time. So who's more powerful? Worker B for sure.
Power is simply the rate at which you're doing work or using energy. All it is work divided by time, and we measure it in watts. So when you see a 100-watt light bulb, it means it's using 100 joules of energy every single second.
So let's tie it all together with this neat little bow. Work is getting something done. Energy is having the ability to get it done. And power is how fast you get it done. See? All connected, but each telling a different part of the story. And that's our deep dive into work, energy, and power. But I'll leave you with one last thing to chew on. If energy can't be destroyed, when a huge, fast-moving car slams on the brakes, where does all that kinetic energy go? It doesn't just disappear. It has to go somewhere. Well, it transforms, mostly into a massive amount of heat in the brakes and the tires, and into the sound energy you hear as a loud screech. The energy is always there. It just changed its form.